Hi, my name is Bob Beechell. In the second video on using matrices, I'll be looking at how to perform operations on a matrix, and in particular, for example, how to delete rows and columns or add rows and columns. So let's look at how to perform basic operations on matrices in R. Before I begin, let me clear the console here to remove all the stuff I've done at the moment. Remember, to clear the console, it's Control L. Okay, now let's remind us of the two matrices that we've actually created so far, which are M and P. You can see that here from the environment pane. Here are the objects. I've created two matrices, M and P. M is 3 by 4, and P is 2 by 4. Now we can view these by, of course, simply typing the name. I'm not going to type them in again here because I've already got them up here. You can easily rerun commands by just placing the cursor on the command line and pressing Command Enter or Control Enter in Windows. So there's M, my 3 by 4 matrix, and here's P, my 2 by 4. So let's consider first addition. Now, of course, if you're going to add two matrices, then they have to be the same dimensions. Again, this, as in linear algebra, that's the case, and it's the case here, because it's simply going to add element to element. Just to show that that therefore won't work here, let me run this command here, M plus P, and of course we get the error saying they're non-conformable. So in order to add something to M, I need to create another matrix which has the same dimensions of M. So I've got a line here to do that. This time I'm creating a matrix which I'm assigning to variable G. It's a 3 by 4, so I need 12 values obviously in here. So let me run that. That creates this matrix G, which we can now view. Remember, of course, that it puts these values in by column, so 1, 2, 3 is the first column, 4, 5, 6 the next column, and so on. Now, of course, of course, if you look in the environment, you'll see G is there. Let me now add them together. This should work, as it does, of course, and what it's done, of course, is added this element here in row 1, column 1 in M to the same the one in row 1, column 1 in G, so 2 plus 1 is 3, and then we've got 5 plus 2 is 7, and 8 plus 3 is 11, and so on. Now that, of course, is the same as in matrix algebra, in linear algebra. Now, what about multiplying matrices? Well, again, as with vectors, standard multiplication here, using the asterisk as the multiplication operator, is not the same as in linear algebra. You're not going to be multiplying rows into columns, where, of course, in order to do that, the number of columns in the first matrix must match the number of rows in the second matrix. Here, when you multiply matrices, it's element by element, just as with addition. So in other words, the first element, the element in this position here, gets multiplied by the element in the same position in the other one, and so on. So in that case, just as with addition here, the two matrices have to have exactly the same dimensions. To show you how that works, let me multiply M times G. And of course we get another 3 by 4 matrix, and the elements are given by multiplying element by element. So this element here in M2 is multiplied by this one here, 1, to give us 2. This one here, 5, is multiplied by the corresponding element in G2, that's 10. 8 multiplied by 3, 24, and so on. So it's element by element. If you want to multiply matrices as in linear algebra, you have to use a different operator. Okay, let's now look at applying mathematical functions to a matrix. Now here you have a choice as to whether you want to apply the function to every element in the matrix or just columns or just rows. Let's take as an example again mean, but obviously there's many others you could use: standard deviation, sine, cosine. There's many built-in standard functions in R. So this line here, mean m, that's going to find the mean of all the values. So it finds the mean of all the elements. Notice how you can put comments here on the same line as your code, and they're ignored because of the hash sign. So if I run this command, this instruction, it finds the mean of all the elements in M. So in other words, it would have added all these 12 numbers together and divided by 12. Now, mostly when you're dealing with matrices, especially when the matrix is a data frame containing your data, you don't want to operate on all the elements. What you want to find is the mean of each column, for example, the mean of each row. Now you can do that easily by using the apply command here. Now, notice, by the way, that when you hover over a command like that, RStudio has a little pop-up, a little tip, showing you what bits of information you can include or need to include in the function, the arguments that function requires. Also, if you want some help on a particular command, all you need to do is to make sure the cursor is in the somewhere in the command itself, and if you press the F1 function key, it brings up the help for that particular function. And here we can see what a standard help page looks like. It basically describes what the function does. It then gives you the basic usage, where you have the command name, obviously in the brackets, the arguments, and it tells you what each one does. Some are required, some are optional. There's some more detail about what exactly the function will do, and then it tells you the value, i.e. what the function returns, what the command returns. And finally some examples. And so the help system in R is very good, and in RStudio. Okay, so what the apply function does is that it will work on a matrix, and it will either apply the function that you specify to the columns or to the rows. Now, to specify that the function should apply to the columns, you put a 2. So notice what you need to put. You need to put apply, and then in brackets the matrix, the variable name of the matrix, comma, and then either a 2 or a 1. A 2 if you want to work on columns only, a 1 if you want to work on rows only, then another comma rather, and then the actual function. So what I'm saying here is find the means of each column in M. So if I run that, you'll see that that's what it does. There are 4 columns, hence there's going to be 4 values. That's the mean of column 1, mean of the values in column 2, and so on. We can probably just check that if we look back to M here. So here's column 1. We've got 13, 15. So 15 divided by 3 is, of course, 5. There's your mean. Column 2 is got to 26. Divide that by 3. It's going to be 8.2, yes. So as you can see, it's done exactly what I told it to. I told it to find the mean of the columns of M. If you want to apply a function to the rows, then you specify 1. So as you can see, this is going to find the sum of each row in matrix P. So let's run that. And there we have our 2 sums. Now matrix P, of course, had only 2 rows here, so there's going to be 2 sums. So the sum of the first row is what? 15, 28, 29, 39. Yep, and obviously the next one is 31. Notice that that is returned as a vector, a 2-element vector. This is returned as a 4-element vector. So you could have, of course, stored the result into a variable, into a vector themselves if you wanted to use those values later on. Now, that shows you how to use a couple of the built-in functions. I say there are many more, but you can actually apply your own functions. I will be talking about how to create functions in R in a later video, but here you can see a simple example. Here I'm applying this function here to the columns of, notice number 2, the columns of M, and what I'm wanting to do is divide each value in the columns by 3. Now the way I do that is I indicate that it's a function, that it's my own function, by using the word function, and then in brackets x. You can put any letter there you like. Obviously don't use one of the letters you've used as one of your variables. So if you don't use x for anything, you can use x here. And then I'm then telling what to do. So x here stands for every value in the column, each value in each column, which I'm dividing by 3. So obviously this bit here, function comma x, that's standard. You'd put that in whatever your function is going to be, and then here you actually put what the function is going to do. So you could have put x plus 3 or x squared or 3x plus 7, whatever function of x you want there, and it will operate on, it will do that to each value in the columns. So this should divide the columns of M, of the value in each column, by 3. So let's run it, and of course there it's done that. So if we go back up to M, you'll see that this is 2 divided by 3, which is 0.66, 5 divided by 3, which is 1.66, and so on. So if you want to perform actions, if you want to use functions on just the particular columns or the rows of a matrix rather than all the elements, this is how you do it using this apply command here. Okay, finally, let's consider how to add and delete columns and rows in a matrix. If you want to add a column, then you use the operator cbind, the function cbind. And as you can see, what you put is, so if I'm wanting to add columns to M, then I have to reassign M by using this command here. So I'm going to reassign to M as it currently stands, comma, and then the additional column here. So this is going to add one more column to M. Now M, of course, is a 4 by 3 matrix, a 3 by 4 matrix. So in other words, there are 3 values in the column, so obviously I needed 3 values here. Notice how that's entered as a vector with the C notation. So this should add an additional column, 921, to M. So let's run it, and then let's have a look at M. And indeed it has added now a 5th column, 921. If I want to add rows, then I use rbind. Same thing again, reassigning to M. So I'm adding to M this extra row. Obviously, because M now contains 5 in a row, I need 5 values here, not 4 as before. So let's run that and see M, and here we are, that's added this additional row. Finally, if I want to delete columns or rows, then I can use this notation here, this way of doing it. It's similar, of course, to what we did up here when we were subsetting, and again similar to how we did it with vectors. So what I'm doing here is removing columns 2 and 4. Notice the comma there. If I'd put 2:4, that would have meant 2 to 4. It would have removed columns 2, 3 and 4. Here I'm removing columns 2 and 4. And again, notice I have to put that into a vector with a minus sign. Okay, so if we run that, it should remove columns 2 and 4 here. And it has. Column 2 has gone, column 4 has gone. I'm just left with columns, what were previously columns 1, 3 and 5. So obviously if you wanted to remove rows, you'd put this thing here first and then a comma, specifying the rows that you wanted to remove. Okay, so that shows you how to use matrices in R.